All right, now we get to look at limits involving infinity. And there's basically two cases. One would be a case like this where there's this vertical asymptote and both sides of the function are going up to infinity. So as far as limits, that would look like the limit as x approaches 4 for this function f of x. Both sides go up to positive infinity, so the answer would be positive infinity. This one, it's getting closer and closer and closer to this horizontal asymptote. The way that that would look with limits is the limit as you follow the graph out to the right. So the way we write that is x is going to infinity. So as x gets bigger and bigger and bigger and bigger and goes out to the right, what's happening to the function? It's getting closer and closer to a 4. So basically with limits involving infinity, we're either going to have an infinity right here or we're going to have an infinity right here. So this dotted line, that's a horizontal asymptote, often abbreviated as HA, and this one is a vertical asymptote. And then let's take a look at some examples. Example number 1. What's the limit as x approaches 4? And then the function is going to be x squared minus 16 over x minus 4. Well, as you can tell, if you substitute a 4 right here, that's going to cause division by 0. So that means we need to do algebra. And the algebra that we need to do is factor the numerator, which could be factored as x minus 4 times x plus 4. And then x minus 4 and x minus 4 cancel. Since there's no more division by 0, we can go ahead and substitute the 4 for x right here. And then that is going to equal an 8. So that is not infinity, and that is not infinity. So this actually is not an example of limits involving infinity, but I'm going to make a point with that in just a moment. First, I want to see, did I get the answer right? So here's the original function. And then if you look at the graph, it does not have a horizontal asymptote and it doesn't have a vertical asymptote. And if you pick a number close to 4, trace and put 4.001, it says your answer should be approximately 8.001. So I'm pretty sure that one's right. Now on to my point. Look at example number 2. Take almost the exact same thing. The limit as x approaches 4. It's got x squared minus 16 on top. It's got x minus 4 on the bottom. Yep, so far that's exactly the same. Now, change it a little bit by squaring the denominator. So what's going to happen? So it's still going to say the limit as x approaches 4. We would still do the same algebra, x minus 4 times x plus 4. And I could even rewrite this one as x minus 4 times x minus 4. And then, so far, the work is pretty much the same. You have those cancel. But then this is going to say the limit, and then as x approaches 4, and then it's going to have x plus 4 on the top and x minus 4 on the bottom, which means that it's going to be an 8 divided by 0. An 8 divided by 0 itself is undefined, but when you're talking about limits, this is really 8 divided by a very, very small number. And when you take a constant and divide by a very small number, you get a very big number. So big that it goes to infinity. And then take a look at the graph and see if that seems right. So this one basically looked like a straight line, but then I change it ever so slightly and have the x minus 4 on the bottom squared. And then take a look at the graph, and this one has an asymptote right here. Now one side is going down to negative infinity, the other side is going up to positive infinity. So I need to adjust my answer a little bit. On the right side, it's going up to positive infinity, and on the left side, it's going down to negative infinity. So really, this one should have said, on the right side, you're going to get positive infinity. But on the left side, the limit is negative infinity. So if the original problem said, what's the limit as x approaches 4? Then that means that the left side and the right side have to agree. And since they don't agree, then the limit does not exist. Because in order for them to exist, they both need to go to the same place. Either both to positive infinity or both to negative infinity, but when they switch and do opposite, then the limit does not exist. Now, what about if we, example number 3, take that same function, x squared minus 16 over x minus 4 is squared. So the same function as example number 2, but this time take the limit as x goes to infinity. So in other words, if you follow the graph out to the right, what's happening to it? So first, take a look at the graph, and as you can see right here, I can't really see that much of what's happening to the right side. So I'm going to have this go from 0 to 50. And then what happens to the right side? So this part doesn't really matter, but as x is going out to infinity, this is getting lower and lower. And if you trace, you could see that it is about a 1.2 right now. Now it's a 1.1. Now it's a 1.1. To speed up this process, I could tell it go out to 10,000. So it leveled off and it's not touching the x-axis, so the answer is not 0. It is close to 1.02. Now it says 1.01. So I'm thinking that the answer is 1. How do we actually prove that? Well, instead of factoring it, what we're going to need to do is multiply out the denominator. So the top can stay as it is. The bottom, we need to square this. So when you square a binomial, you need to square the first thing, that's x. The middle term will come from multiply these two, which is negative 4x, and then double that result, negative 8x. And then square a negative 4, so that's going to be plus a 16. Okay, so if x is going to infinity, this is going to be infinity squared. And infinity times infinity equals infinity. Then subtract 16. Well, when you have an infinity and you subtract 16, the subtracting 16 really counts for nothing. This would be like, say you go up to Jeff Bezos. He's got an infinite amount of money. And then you say, hey Jeff, could I borrow 16 bucks? He gives you the 16 bucks. How much does he have? He still has infinity. The same thing happens with this 8x and this 16. So really all that matters is the x squared on top and the x squared on bottom. And x squared divided by x squared equals 1. Now that's not the way to prove it, but that's a start. So what you do is you find the most powerful term. So 16 is not that powerful. An 8x is not that powerful. X squared, that's the most powerful term. So in this one, the most powerful term is x squared. Then divide every term by that x squared. So it would look like take the limit as x approaches infinity. Here's my main fraction bar. On top, there's x squared minus 16. So each one of these needs to be divided by x squared. And on the bottom, each one of these needs to be divided by x squared. So what I'm really doing is I'm multiplying the top by 1 over x squared, and I'm multiplying the bottom by 1 over x squared, and then I'm distributing. So it puts the x squared on the bottom of each and every term. But rather than doing that each time, then you can just combine those two steps into one. And then what happens is we get the limit as x goes to infinity, and then reduce. This is just going to be a 1. 16 over x squared cannot be reduced, it stays that way. This would be a 1. This term, you could cancel one of the x's, it would leave 8 divided by x, and then plus 16 divided by x squared. Now with all of these terms that have an x in the bottom, this is basically saying take an 8 and divide it into an infinite number of pieces. How big is each piece? Well, if you take an 8 and divide it by an infinitely big number, the result is infinitely small. And it's so small that it counts for 0. So all of these that have an x on the bottom, they all go to 0. Which means that the answer is going to be 1 over 1. Which is what the calculator was trying to tell me, that you should get the answer 1. Now, let's do another one like that is just a little more challenging. I mean fun. Example number 4. So what is the limit as x approaches infinity if on top it is the square root of x squared plus 9 divided by a 2x plus 8. So we're going to do the same thing as we did last time, but another thing that you can do, so you could graph it in order to get an idea of what the answer is supposed to be. Also, you could approximate it. So this is approximately like, so the x squared is the most powerful term in here. The 9 doesn't really count for much if this is going to infinity. So the top, I don't really need the 9. I would have the square root of x squared. On the bottom, I don't really need the 8. This is the most powerful term. So on the bottom, I could approximate it by saying it's 2x. So on the top, the square root of x squared is just going to be x. So it's going to be x over 2x. And after the x's cancel, we're left with 1/2. So my estimate is that the answer should be 1/2. Now let's do it like the last one and actually prove it. So take the limit as x goes to infinity. And then you look at all 4 terms and which one is the most powerful. Well, x squared is the most powerful, but the thing is it's inside of a square root. So once you simplify that, that's an x. So really the most powerful term is just x. You might say, well, 2x is more powerful than x, but really we just need to know the power, not the exponent in front. Because with the exponent in front, that's like this 2 is going to stay there. And if it's supposed to be in the answer, it's not going to get canceled. It will just stay there. So you don't have to worry about the 2. Just use x. So here's the original square root of x squared plus 9 over 2x plus 8. And then, since x is the most powerful term, you multiply by 1 over x. So multiply on the top and multiply on the bottom. Now, how do you distribute this into a radical? Okay, over here on some scratch paper, I'll just explain real quick. So let's say you have the square root of 9x. So that's not a part of this problem, but just bear with me for a second. How do you reduce this? So you can take the square root of 9, and that goes on the outside of the radical. The square root of 9 is 3. And then it would be 3 radical x. And most of the time we go this direction. You're given the square root of 9x, you reduce it and rewrite it as 3 radical x. But what if you wanted to go the other way? What if you want the 3 and you want it to go back inside the radical? Well, if you want it to go back inside the radical, you'll need to square it. That's what we're going to have to do right here. So to put this 1 over x into the radical, we're going to have to square it. So there's the x squared plus 9 that was originally there. And then this will become 1 over x squared when you put it inside the radical, which means that each denominator gets turned into an x squared. Now this one doesn't have a radical, so you could just go ahead and distribute. So that would be the 2x plus the 8, and then each one gets divided by an x. All right, now we've done the hard part. Next up, simplify. So for the numerator, this is just going to be a 1 plus 9 divided by x squared. And then this, when you reduce these x's right here, that's going to be 2 plus 8 over x. And just like with the last one, if something has an x in the denominator, a 9 divided by infinity is so small it counts for 0. And the same thing right here. So that means all that's left on the top is the square root of 1. All that's left on the bottom is a 2. So my estimate earlier was correct. The answer equals 1/2. And then let's do one more. So for example number 5, what's the limit as x goes to infinity of 42 divided by 1 plus 5e to the negative x? Okay. The first thing that I would do is, I don't especially like negative exponents, so I would rewrite that. So the 42 can stay, the 1 can stay, the 5 can stay, but a negative exponent means that this one was inverted. So it means that the 5 was actually divided by e to the x. And now we're practically done, because e to the infinity is going to be equal to infinity. And that means this one is 5 divided by infinity. And again, 5 divided by infinity is so small that it counts for 0. And so then the answer would be a 42 on top and a 1 on bottom. So the answer is 42. And then I just want to graph and make sure that I got that one right. So the original function was 42 divided by, and then 1 plus 5, e is raised to a negative x. And that should be in parentheses so the calculator knows this is the denominator, that's the numerator. And then it's going out to infinity, so 0 to 10,000, that sounds fine. And the answer is 42. So I'll make it go up to 50 so that we'll be able to see the 42. And you can see it jumps up really fast and then levels off. And if you trace, it says 42. Yay, we got it right. All right, well, I'll talk to you in the next section.